Hey, everybody, welcome back to another episode of Building Scale, specifically the Building Connections series, where I get to connect with people mostly here in the Valley in Arizona, specifically Austin Trautman, who I got introduced to by another guest, James from 180 Degrees, my friend there, designing and building buildings here in Phoenix. So, one, thank you, James, for the introduction. Two, our conversation, mine and Austin's conversation, was pretty awesome. I was very energized. I usually don't record these intros until a little bit, like I give myself a little bit, but I was all jazzed. I was just super jazzed up, and we got to talk about healthy homes. Like, what does that mean in regards to materials you build with, how it impacts the world, how people live in them, and what is happening in the home to make it healthy. It was just really fascinating, fun. I nerded out. We talked about nature, Grand Canyon. I just got a lottery for it, and me and Austin talked prior to that about that. But his idea of this different life, different way homes can be built, he had a full moment in the Grand Canyon. So I thought it was pretty fitting there, and I think you'll enjoy this episode. If you're thinking about building a house or any structure at all, and you want to just have a different way to look at it, maybe use different materials, just how the house performs as a whole, this is a good listen for you. Both for builders that have done this for a long time, as well as maybe some random person that is crazy like me that says, I just want to build a few houses in the middle of the wilderness and live with all my friends. So anyways, I think you're really going to enjoy this episode. So here it is. Awesome. So Nopal, I love the idea of Nopal. And when you were explaining that it's not just one and it's many and it could be interpreted different ways, I got all nerded out on it. Tell me more.
Maybe you tell me more.
Yeah, well, I think of Nepal like as in like the place you go to climb big things. I think that's right. I think maybe my geography is just that bad that I don't even know, but that's what I initially thought. But when I butchered this name before when we were talking, you were like, oh yeah, it's supposed to be interpreted the way you choose to interpret it.
Yeah, I mean, to us, it is Nepal, like a reference to the prickly pear cactus from the Southwest, from where we live, used by native cultures in the Southwest and Mexico. And there's a deeper meaning to that of humans living with nature, understanding and being with nature long enough to know how to live most efficiently, appropriately, present, and a happier existence rather than trying to conquer and be above nature. But it is also a word you can pronounce different ways, and kids generally pronounce a lot of words, especially Nepal, different ways. And so I think it's fun. People can interpret it as they see fit as well, which is, add some playfulness to it.
See, how you described it was poetry, and then what I said just sounded like nonsense. See, that's why I needed you to say it.
Both are true.
Yeah, both are true. That's the beauty of the word, I suppose. So healthy homes, right? Like overarchingly, how you build, how you live in, how you think about not just the home, but external factors to that, whether it be somewhere else in the world or your immediate surroundings. Where did this drive for a healthy home come from?
Good question. There's 4 of us in the company, and the path for each of us is probably a little bit different, but we all have been on this journey over the last 15, 20 years of what a house should mean and what a house can be. And oftentimes houses become this vanity metric to show our status in the world. And we forget about the people who live inside of the box we're designing and building. And we forget about the people that are building the box and the people that are creating the materials that go into building this box. And we forget about what the box is going to be 20 years from now when you want it to be something different, or 200 years from now and it's got to gone. It's done and it needs to be disassembled. And we've walked these paths to reach the spot today where we're considering humans, really, I guess. It's just, what are the humans who are involved in this house, and what is the user experience of this house? What is the carbon impact? What's the social impact? What's the health impact, both short-term and long-term? So mental health and your recovery the next day through measuring and optimizing things like CO2 levels and VOCs. What does it feel like to be inside that space? So things like biophilic design give signs and guides along the way to how we design to feel better inside these spaces.
So it's essentially the whole supply chain from every piece of material all the way through the inhabitant or inhabitants in the home, and how they then feel on day 732 of living in this house.
Yeah, I like that.
That's pretty encompassing. That's a big stretch. Let's start in the beginning. So obviously, to build any home, any box, as you say, you need materials to do that. So what does a healthy home look like compared to a not healthy home when we think about just materials?
Yeah, so good question. We have a saying, materials create the results, and it would you could think of it similar to food. If you give a bunch of rotten or unhealthy ingredients to the best chef you know, your meal is still going to be pretty mediocre. And we seem to have forgotten that in building buildings as an industry. A lot of the materials we're using are just mediocre, kind of rotten materials. But that doesn't have to be that way. Part of this story comes from synthetic materials change the way we think about buildings. We've increased the performance level, the required energy efficiency, for example. And the easiest way to do that was this shift from natural materials to synthetics. And so synthetics created a higher expectation of performance within these buildings, but didn't really deliver on it long term. Now we've kind of come full circle where these natural materials are now performing at a higher level than the synthetics and doing it without the inherent risks. And so we've kind of gone back in time, but forward in time at the same time. So
that's a lot of time.
Yeah, a lot of time. And so today we have a really great ability to use amazing materials that are generally natural in nature. So things like wood fiber and sheep's wool processed into different materials, different usable items. You can come up with buildings that breathe moisture a lot better, that protect themselves a lot better, that are more energy efficient, that are healthier. And then you get into systems like adding essentially a lung to the building. So having balanced fresh air that is breathing all the time, exchanging bad air from outside the house, bringing in fresh air from outside, but also filtering that air at the same time.
Okay.
So yeah, so you just end up with these components that create a different whole, but you have to look at the component and material level before you try and assemble into a whole.
That makes sense, right? Obviously, the chef analogy, I think, hit it on the head, right? Like you could have one type of fresh fish that was caught that day from one fisherman that literally caught that fish in the middle of the ocean or in the ocean compared to like, oh, well, this is a farmed thing that has been copied and genetically modified to whatever degree, then there's a very different taste of those things, just as in general. And what you're putting then into the end user, also very different, right? That's pretty straightforward. So you mentioned like the wood fiber, the sheep wool, sorry. So why not, I guess, why, now that we have more information and it's accessible is I guess the assumption here that I'm making. Why not use that material in comparison to whatever other insulation is where I'm going to go with? I'm assuming that kind of those two items go into. Why not use the other material if they are just better?
Why are we not using it, or why is the industry not using it?
Why is the industry not using it? Like, because if the industry was using all this, you guys would probably be pretty stoked about that idea.
Yeah.
Like, oh, hey, like yes, please, let's use the good stuff, right? Why not? Like, why, when you think of just a house builder, they're not saying like, let me use this material, this type of insulation in comparison to something that's manufactured?
It's a good question. There's probably a few good answers. I think the main two are doing what you did yesterday. A lot of times we just, that's present everywhere, but especially in construction. There are so many things when you watch a house or any building get built. And we experience this with clients all the time who are looking up close and say, why is that happening this way? That doesn't seem to make sense. And there are so many things that are just done because of habit and convention. And we are moving in this better direction, but we've had such a push for things like energy efficiency defined through modeling and through the easiest, not even easiest, but cheapest, somewhat simplest material possible. So we end up with materials. Reason number two is we end up with these materials that are promising to do a lot of things at once, which that feels inherently easy. Spray foam would be the best example. We have a requirement for buildings to be a certain air tightness, a certain insulation value, but we really just focus on our value, not the whole equation. And then a general recommendation / requirement that they handle moisture fairly well. The promise of spray foam is that it can do all of those as one material that's cheap and easy to install, and it's a miracle material. So, and the marketing's great, so people jump on that, and we use that
So
material
watching the guys spray the
everywhere.
stuff,
Yeah,
it's mesmerizing. Yeah,
and
no question.
and when you're the sales pitch to the people to be the installers is just as good, right? It's you're a hardworking, smart chemist of a person who's able to do this thing and dress up like you're work for the CDC during an outbreak in a hazmat suit, but you're not afraid of hard work. So, this is the work for you. But it's insane. Like, the material doesn't actually do these things that it's promising to do. And we have enough information out now, both in lab tests, but more importantly, real world tests and empirical observation, to know that the lofty promises a lot of these synthetic materials are not true. But I don't think we've fully caught up to that understanding yet. We want to believe the story that we can have it all for less and easier.
Sure. Well, that's
yeah,
the dream of every day of most people's lives, right?
For sure. Yeah. For sure. And I think part of it is like we're afraid of doing the work or taking the harder route. We want the easy, comfortable solution. But what we find is that when the work is good work and you can eliminate a lot of the frustrations and the sidetracks and the annoyances that are rampant in a lot of things, especially construction, doing the work is really enjoyable. And a lot of people enjoy doing the work or enjoy being more connected to the people who are doing the work. And so things like sheep's wool, I had my, at the time, 3-year-old help me insulate this building with sheep's wool. I had a giant pile of wool that we dumped out of bags and rolled around in and played with.
It's awesome.
And
I wouldn't necessarily recommend that with most insulation, by the way.
No, I don't want to do that with any other insulation. Maybe some wood fiber. I'm certainly not putting a toddler in it, but with sheep's wool, you can.
Yeah. You also mentioned not just material, but the systems or design. You said add a lung into the home for fresh air. That to me, that I don't understand this. My brain says, like, what do you mean you added a lung? Like that sounds awesome. How do I add a lung? So this is kind of where my brain goes. How does that work, or what does that mean?
Yeah, it's a good question. So we have a saying, most ventilation sucks.
Okay.
And that essentially is every building needs some sort of ventilation. There's people inside breathing, creating CO2, doing things, creating chemicals.
Silly people breathing inside, making the air too much carbon.
Which actually turns out to be a much bigger issue than you would expect. That's a side point we won't get into, but there's more and more, now that we're measuring more in buildings, there are incredibly high CO2 levels, especially in commercial buildings, that are wreaking all sorts of problems, both mental and physical. Harvard had a really good study on this, so we can, get into a different time, but it's a fascinating topic. So most ventilation sucks. Most ventilation, you've got now increasingly more airtight buildings. You've got a bath fan or something that's designed to run often, maybe 24 hours a day. It's sucking air out of the building and depressurizing that space. It's getting fresh air by bringing in makeup air wherever there happen to be cracks in the building. So in California or the Northwest, that's through crawl spaces, most often also attics. In Arizona, we're slab on grades. We're pulling air in through cracks in the walls in your attics. What are you bringing in from that wall? Is there mold growing in their wall? Is there rat poop in your attic? Is there fiberglass that you're sucking all this air through? So not only are you not conditioning the air, not filtering it from the outside conditions, whatever's outside that you don't want, you're also most likely polluting it by whatever it's bringing in. And then you end up with building system problems of humidity, for example, in that air, especially someplace like Arizona where it's warmer outside, there's more humidity in the air, even if it's low relative humidity. And so that humidity is getting left inside that wall. If that wall doesn't have the ability to dry out, which a lot of the synthetic materials decrease that ability for it to dry out, increasing your risk, you just end up with an almost guaranteed set of problems. Versus this lung system is balanced. It's constantly bringing air out of the spaces you don't want, like kitchens and bathrooms. And then it's bringing an equal amount of fresh air, filtering that air, preconditioning the air through humidity, and in the case of an ERV also, or temperature, and in the case of an ERV also humidity. And then it's applying that to places like bedrooms and living spaces where you want fresh air.
Well, that sounds lovely.
Yeah.
It also, and I've lived in a house my whole life, like inherently, and I've never thought through the like, oh yeah, like air has to exist in here for me to be able to breathe. That's pretty straightforward. I don't always have the windows open, so like there must be cracks in places that allow this to happen. But how, everybody says, oh, you need to go outside and get some fresh air. So it's like, oh, well, then inherently the levels of air is different in a home. And yeah, if you make it more and more tight, seal it tighter and tighter, that decreases the ability to get fresh air in. Okay.
Yeah. And often you have air outside. There's things outside you don't necessarily want inside, even though interior air is usually worse than outside. Interesting things happen in the buildings built this way. We have another saying of step inside for fresh air.
Okay.
Because our interior air quality is almost always better than outside.
Okay.
And exponentially better than a typical indoor air quality.
So you're talking about indoor in your builds, or the philosophy of how y'all are building.
Yep. Correct. Okay. And that used to be, we know it works for high performance buildings that are highly air sealed and have balanced ventilation and whatnot. But we also we have a video that'll be out by the time this comes out. Just last month, one of our partners, Lucas Johnson, our chief building nerd, just installed a best practice ERV and ductless mini splits in his house, which is this amazing experiment over 7 years of doing truly good low performance. So saying we're not going to try and push high performance and super energy efficiency, but we want this space to still be as healthy as possible and as low carbon and high on social justice factors and things like that. So he's done a lot of steps over the last 7 years, but we just installed this HVAC system and he's had a few weeks with that. So we have a video that explores that experience as well. So you can do it at low cost at a typical leaky block house.
Okay. So it feels like you guys are just like always testing, and I'm like building. Either you get your hands on a building where it's like, we'll just do this at my house, or we'll just do this at my my work studio, or we're gonna just do these in different places and then test. Right? You're just scientists, right? You're just testing a bunch of stuff all the time, and then like comparing to like what the current built environment does when it comes to homes. And then saying, hey, these are our findings, almost guide-like.
Yeah. So true. A big chunk of what we do is we call it applied research. And if it feels risky, we'll do it ourselves. Like this box I'm in, I wouldn't necessarily say it was risky. We knew that it was going to work, but we wanted to try some specific materials and techniques or push some boundaries that we weren't quite ready to do in a client's project. So we did them here and we tested them to see how they went and shared what we learned. Other times we know that this is the industry best practice. And in those cases, we're doing them for clients. Like this is the best thing we know today. Through all of this experience, I think it happens in 3 phases, right? We do the doing, and the closer you get in on the doing, the more you are hands-on, the more you can see how these pieces connect. And then you gather that information. So you say, okay, well, when you do it this way, here's what the results are. And then most importantly, you make insights out of that. So you say, okay, we've got all these results. We've had scientific testing for decades on a lot of this stuff, but the end builds often feel more like science experiments than places people really want to live in.
Okay.
Or on the other side, from a pure architectural experience, the experience of the space in an optical condition might be amazing. But if you have these other things that are deteriorating the space or detracting from your experience, it kind of falls apart or it becomes not worth it over time. So those insights are the really important piece. And we help people in a couple of ways. We do full builds, often our own design. So we'll design with a client and build. We help clients do their own builds, whether we're doing the design or we're filling in some of the design pieces. If they want to be hands-on, either they're self-GCing or they just want to know the process, we help guide people through that on a similar path to what we've walked on. And then we're trying to get further and further towards sharing these insights in an actionable way for people who are going down this path on their own, for free and low cost as well. So YouTube videos that are not necessarily a tutorial of this is how you do it, but it's more this is what we're learning that you can apply to your own space. And then long term, some other bets there that will go further down that route. But really, it's if you want to be hands on with your build, either doing the work yourself or just knowing how it's getting built and being part of that process, we want to help you do that in the least frustrating way to get the best results possible. And hopefully avoid as many of the pitfalls that are there, right? Like you ask these questions of these pitfalls they're really obvious to us where we sit now, but they're not immediately intuitive to most people, even in the industry.
It's very wild to me because that idea passes through my brain all the time. Like, oh, this seems obvious, but like, 6 months ago wasn't as obvious to me because I just walked the path of whatever it is. And I mean, literally the podcast, when we started the podcast, it was literally like, how do we just help people get over or try to speed up the things that they're going to encounter, the failures that are almost inevitable if you don't have anybody giving you at least a heads up on something. And so I think about that all the time of like, how can you just speed up the process? So if I wanted to build my own house or build my own work studio, it'd be like, okay, I would inherently try to find somebody that has done this in some way because I am not a builder. Like, I'm not that. So it's like, oh, how do you, I mean, just starting with the foundation, it's like, how does that work? Like, how does that even, I understand that there are 4 walls and there is a roof, but like, how do you get those 4 walls and roof not to fall over? What does it need to stand at? We're sloping and all kinds of different things that I now have a better idea of because I've had 200 conversations with leaders in the built world. But like, I still would have no like actual concept of like, how do I actually make this a real reality, which I love because even if I didn't do it, like say I was like, I'm building me a workshop in the backyard, it'd be like, even if I wasn't going to build it, I would want to know, well, how is it actually being built and what does that look like? So I certainly fall into your demo.
Perfect. Yeah. No, you're 100% on of exactly what we're trying to facilitate.
Yeah. Not to mention my deep dream of a compound in northern Arizona with me and all my friends. I assume that's everybody's dream. They just want to live with all their friends and like all have your own houses and you share some common areas and it's awesome and it's wonderful. I don't know. That's I'm a crazy dreaming man, but that's just the life I live. So we talked about the materials and we talked about like being in the house. What does design do? So obviously the lung was a good example, but like what are other pieces of design, how people should actually live in their home, right? You said homes have kind of fallen away from like the idea of Nopal. See, I connected that. It's pretty good. How should that look today? And like, how does design play a role in that?
I am not our chief design expert here, so I will try not to go too far down into architecture language, but I am a fanatic of experience within a space. And I live in a building we built 8 years ago now, and I live there with 2 young kids. And so I know the experience of living in, and we actually had that building on Airbnb for 4 years. We had a lot of people through that space, and it was really interesting. Most people booked it because they looked cool and the location was good. But then we'd get messages from people in the space along the lines of, I feel really good in here. What are you doing?
What are you pumping into the air in this building?
And that was the most common thing people would come to. They say, I heard Vegas pumps oxygen into buildings. Are you doing that? Like, well, kind of. We're eliminating CO2, which basically is the same effect, So there are a number of principles we really focus on, biophilic design being one of them. That's really interesting. Basically, the idea is that humans feel better in nature, but most of us want to be more comfortable than we are. This is not part of biophilic design is people feel better in nature. How do we bring that to buildings? The challenge is most of us feel uncomfortable in nature. Our modern day desires are for a higher level of comfort than you get in nature. And so how do we bridge those two together? And it's been part of a lot of really great designs for a long time, but now we have these scientifically tested and observed principles that once you understand the basics of them are really fun to design with. There are experts, there are architects that are experts and guides, consultants that are experts in implementing these pieces. But I actually find that just general homeowners, once they understand the basics of them, start drawing really interesting conclusions. So there's things like Refuge Prospect that describe spaces where you feel safe. Like if you have a space behind you that's inherently closed off, but you can see out, that feels like caveman days when you're in a cave and you're safe, but you can see out for anything that's going to attack you.
I want to pause you. It is not that I'm like, oh, Mr. Nature guy. I'm living outside all the time, but I will tell you that without question, the best moment, I feel best when I am out doing a thing, right? Even if it's walking on a trail, right? So nothing like deep in nature, but it's like, oh, you went to a national park, you walked around a trail. It's like to me, I would assume that's probably the problem. All humans would just feel a way about that experience, right? Like, so it makes sense to me saying like naturally we probably feel more connected to nature, but on the other hand, man, is it easy to, live in your house and watch your TV or, use your blender or whatever the normal common I'd say luxuries that we've created as human beings nowadays.
Yeah, so no, you're totally right. I mean, it's tested now. There's a bunch of brain chemistry and different tests that everyone feels better. Your hormones, your responses to the world are better regulated. You're more present, you're more human, you're more creative, you're less affected by things giving you anxiety or concern when you are connected to nature. So, out on a walk, it's out on a walk on a trail in nice weather. I mean, most people could picture that probably feels better to them. And this happens through very observable ways of reducing stress hormones and a number of other things. And it does happen to basically everybody. And there's a really interesting study where they tested the effect of simply changing the surface materials inside of a space and putting people in them. They measured, I believe it was blood pressure, cortisol levels, some other stress responses. And they wanted to know the percentage of surfaces that had to be natural to create a better experience. Or first was if they would, right? And so they found a very specific, if you put people inside of a box with no natural materials, their stress hormones go up. If you put them inside of a box with 60% or more natural materials, their stress hormones go down.
Wow. Okay. That we interviewed the chief innovation officer at Gresham Smith, so very large firm, and one of the big things that he discovered was they tested stress in environments, right? Like this literally used like a smartwatch or whatever to be able to test. It essentially was a connection of heart rate or component to then how stressed you feel in an environment, to then build environments that are less stressful. And the idea was like, how do you avoid like an accident if you're a train station or something you're building, or a bike route or bike lanes and stuff like that? How do you decrease the stress, because that would increase safety, because if you're not stressed you're not like freaking out, which was just a wild thing. So that to me seems right down that path of like, just put different materials in your house, and like that in itself, or if we build with different materials, then you may find yourself just less stressed in general, even if it is hard to tell in the moment. It is a fact that you would be less stressed.
Yeah, 100%. I love that story. And that's, so it compounds all these things, right? There's materials that you can see and feel. There's the quality of the air. There's what does the space feel like when I'm in it? What can I look out onto nature? Can I see the wind when it blows? Do I feel connected to this space? Do I feel calm and focused? And what you find, so one thing nature brings is this passive attention. There's enough interest happening in nature that your brain stops trying to figure out what it's looking at, and it just observes without having to put too much energy into it. And that's why you have insights while you're walking or showering, for that matter, similar effect. And so people are more happy and fulfilled when they are passively, when they can focus on an active task. So like reading, for example, is more interesting than watching TV, because TV is this high level passive entertainment, whereas
Yeah.
nature is this low-level passive baseline that allows you to be creative on top of that.
Interesting. I could nerd out about this for a very long time, Austin.
Same.
Yeah. Okay. Before I go down total rabbit hole of crazy things popping off in my brain, what about where materials are sourced, right? So like obviously you want to have natural materials. You want to create spaces that are healthy for people. What's the impact outside of the literal, essentially, that y'all are trying to look at and see and be conscientious of?
Yeah, great question. I think the two easiest examples, just stick to sheep's wool. Sheep's
Mm-hmm.
wool and spray foam.
Mm-hmm.
You can just look at the supply chain of each of those, and they're not complicated. You don't have to get into a ton of detail. Sheep's wool we get from a company called Havelock. It's an amazing company. They're using wool from mostly New Zealand, but other countries now, that is surplus wool from the industry. So this is wool that was getting thrown away. It's not used in textiles and things for various reasons. They've got a really great way of packing this down to ship it, ironically, across the world, but in a very low carbon way. The way it's shipped, it's carbon neutral or carbon negative because the sheep are creating this. You're putting carbon into the material rather than the other way around, right? So carbon's coming out of the air into the material rather than carbon burned to produce the material.
Yep.
So even after all the shipping, you're still carbon negative. The way it's made is very simple without using any toxic ingredients. The way it's turned into insulation. They have amazing ways they've developed over the years to create this into now what they call pro bats that are these really great, squishy, easy to install bats, because one of the complaints previously was wool is hard to install, which ironically homeowners didn't care too much about, but pro
They're
installers.
not installing it.
No, they weren't. So when homeowners were installing it, they're like, this is great.
Okay.
I love this material. I love touching it and feeling it. And I don't have any of these, I don't have to wear a mask. I'm not itchy, but it was slow. Where pros they didn't want to slow down, right? They wanted the speed of fiberglass. So now you have the speed of install, but still a much better material. It's great to work with. Once it's in the building, it buffers chemicals, it buffers humidity. Generally, the wool itself wants to be at the proper humidity that people and other natural materials want to be at. So it protects from built up moisture and mold and things like that in your walls. Just a really great material all around. It does cost more as far as an insulation goes, but if you look at the total cost of a build, it's a rounding error, really. Other extreme, look at spray foam. War for oil-based product, turned into the chemicals that we create foam with in toxic factories that are creating less than ideal situations for people in the factory, people around the factory. Installing the material is difficult at best. I mean, I know there's a lot of talk of how to install foam properly, but outside of a lab, it's really hard to do reliably. And even if it is perfect, it's a much less than perfect material. So you got to dress up like you work for the CDC during an outbreak to install the stuff. You've got to hope that it goes well. It's toxic to install. It's got a lot of VOCs. It's highly flammable. So there are entire counties and soon maybe states that are preventing firefighters from entering buildings on fire that are known to have spray foam.
Makes sense.
I mean, it's like I think that's probably the easiest example of, which material do you want to use? And I think what we find for us is that you can debate a lot of these minutia, these metrics along the way, and you can get stuck in those debates easily. But once you walk enough of the path and you know enough of the details, a lot of these decisions become binary. There's just no way I'm using one, and I really want to use the other.
Okay, interesting. And then again, when you're thinking of impact, not just on that home and the occupants of that home. Okay. So I know that one other thing I want to hit on before we wrap up here is you can have a 2-person team build a house, which I think in modern day, that sounds, pardon my French, like bullshit. Like that sounds crazy. Like that sounds insanity. But y'all have been able to do that. One, why? How?
Sure. A couple of years ago, I would have agreed that it sounded insane. Is kind of a conclusion we've come to over walking this path of how we want to help people create buildings that are more buildable by people. So what better way to do that than to build it ourselves? And what we found is one thing we found is that a lot of assemblies in buildings and the process of building even a small house is too complicated. Things are expensive and the end results are less than ideal, largely because there are so many steps and so many specialties, and everyone's trying to shift risk and do their little piece and not worry about the whole. And so by designing a house, by committing to building it with two people, we had to design it in a way that it was buildable by two people, and two people with reasonable skills could do each step, which biased us towards more precision and more assemblability and healthier materials and thinking about the house as a whole, not a collection of parts. So yeah, right now we're building the first one of those as two people. And that has led to a lot of very deep learning that we wouldn't have gotten to otherwise. You notice things like footings and rebar are a really messy process. There's not a real good system for exactly how that assembles together. While you can panelize framing systems in various ways and make that happen in 2 days, you're still struggling with all the other pieces like footing rebar. And that still is slow and frustrating and expensive and not assemblable. So one of the big learnings out of that is how to make things more assemblable. And then we're creating systems to help improve our own process. So a system we design it, we build it, we update the design, but then also create a system to make the design and the build easier and do that in cycles. And the eventual goal of that is we are currently helping more and more people with that through our guide service. So we can build it for you, or we can help guide you through the process of building it or having other teams build in a more logical human way. And then eventually we want to keep marching further and further down that road to making this easier and more logical for people to design their own spaces, whether you're a professional architect or design builder or carpenter or just a homeowner. Like you said, I have no idea. You're an expert in this field compared to an average homeowner. And it's still confusing of how to build a thing step by step. And that's not uncommon. Like people feel that all over in the industry. And so why is that the case? And how do we undo as much of that as possible? How do we get people closer to the enjoyment of building and designing in a way that things get built rather than designing in this bubble to then toss it to the bubble of building and have all these disconnects?
All right. Okay. So I believe you. I want to come see this two-man work team, though. That's I want to see. I want to put my own eyes on it, essentially, because I just find it fascinating. I just like, to me, which when you initially told me this, and you're like, you got to think like 100 years ago, that's generally how it worked. Like we weren't having 17 trades come in and do everything. It was more like, you're gonna just kind of build things, you and your neighbors or you and your family members or somebody like that. No, I love it. So this has been awesome. I've had a blast. I love everything you're doing. So I'm super happy James introduced us to each other. Before we say our goodbyes, is there anything else you'd like to tell the people?
No, thanks for having me. This is awesome. I'd love to have more of these conversations, get more of the message out. I think people want to follow our YouTube is fairly active. We're doing videos on the process of building this house and other projects we're doing, and you can kind of get a feel for the work we're doing. And then we have a monthly newsletter to share some of the favorite insights we've gotten or links to other people doing cool things. You can sign up for that on our website or get to it through our YouTube as well.
Cool. I will drop all the social stuff in the show notes. And if somebody wanted to get a hold of you, what's the best way for them to do that?
Just on our website, you can actually just book a free 15-minute consultation. We'll hang out on Zoom, similar conversation to this, and just tell us about what you got going and see if we can help you.
Cool. This is awesome. I look forward to many more conversations about this and eventual compound built in Northern Arizona that we all do together. So this has been great. And until next time, listeners, adios.
Thanks for listening to Building Scale. To help us reach even more people, please share this episode with a friend, a colleague, or on social media.
Remember, the 3 pillars of scaling a business are people, process, and technology.
And our mission is to help the AEC industry protect itself by making technology easy.
So if you think your company's technology pillar could use some improvement, book a call with us to see how we can help maximize your IT and cybersecurity strategy. Just go to buildingscale.net/help.
And until next time,
Keep building scale.
scale.